So in the previous lecture, we discussed about different types of flows like laminar, turbulent, and transition. But then we had a question that if we are watching the fluid flowing physically with our eyes, so we can kind of guess if the flow is laminar, turbulent, or transition. But if you are sitting in an exam, or if you are just in your office and you have been given some values by any of your team member who have noted that down by visiting the site, and he saw that the fluid was flowing there with this velocity, this length of the section and everything, and he gives you certain values or parameters, how would you know if the fluid flow was laminar, turbulent, or transition by just having some values, right? So that's what we are going to know in this lecture. So for that, we have a formula which is Reynolds number. It is called Reynolds number. So just for the explanation of Reynolds number, after exhaustive experiments in the 1980s, Osborne Reynolds discovered that the flow regime depends mainly on the ratio of inertial forces to the viscous forces in the fluid. The ratio is called Reynolds number and is expressed for internal flow in circular pipes as. So the ratio or the formula is inertia forces by viscous forces, or inertial forces by viscous forces. Now inertial forces are represented as L V rho, and viscous forces are represented as mu, which is the dynamic viscosity. The L is length, V is velocity, and rho is density. If I write it here like this, right? So you can see the details of these parameters are written. L, length, unit can be meter or anything. V is velocity, rho is density, mu is dynamic viscosity, and nu is also used in another formula which is LV by nu. Basically, density, as far as I know, is equal to dynamic viscosity, which is mu, by kinematic viscosity, which is nu. It's written something like that. But if you want to replace these values with another value which is nu, so you can say that density by mu is equal to 1 by nu, and then you can write it here like 1 by nu, right? It's written here. So that's how you can write these formulas, either this way, either this way. So let me rub this from here. Using this formula, you have first of all the length. So the length can be the section of the pipe. If this is the whole pipe and you are trying to find the kind of a fluid or type of a flow in this specific section, so you can take the length of this like L1, imagine this is L, right? And you can take the velocity at this particular section, you can take the density of the fluid that is flowing in this, and the dynamic viscosity of that as well, right? That's also important. Or if you want to make it more shorter formula, so you can take LV in kinematic viscosity. Now this is important because in your problems, in your exams, in your examples, you will be given either these values or maybe you will be given these values, so you can use them in your formula and find that. Now okay, if you find the R value, which is Reynolds number, then what? How would you know if this is laminar, turbulent, transition? So this is how you would know. And yeah, Reynolds number is a dimensionless number because it is dividing forces by forces, so the units cut or cancelled out and you are having no unit, right? So dimensionless. So here we go. How would you know if this is laminar, turbulent, transition? If the value of R is less than 2000, so you are good to say that it is laminar flow. If it's in between 2000 and 4000, so it's transition. And if it is greater than 4000, so you can easily say that it is turbulent flow, right? Here they are just showing an example that usually is conducted in laboratories where they are also having a dye so that it can give us a color, and you are having the pipe and the flow, the fluid is flowing, and you can say if this is laminar, turbulent, transition by just watching it. And this is the formula there, right? Now in this formula you can see instead of length they wrote D, which is diameter. Now in case of pipes, you can also take the diameter and velocity and density, and mu remains the same, right? So either you can use the length if it's feasible with your values, or you can take the diameter. If you have been given the diameter of the pipe, you can use that as well and find if the fluid flow is laminar, turbulent, or whatever, right? So this is uh, how you can say if this is laminar, turbulent, or transition flow. So I hope you understood about the Reynolds number and the recognition of if it's laminar, transition, turbulent. In the next lecture, we will discuss a new topic. So thank you very much. If you have any questions, you can leave them in the comment. Thank you.